Hi there. I hope you guys are excited to see how Perlin noise works and how to use it. And to demonstrate the Perlin noise unit, I'm going to use the project from How to Use Unity Bolt Units number 4. You can find a link in the description to that video. And to save some time, I'm going to continue from that project. Because in this video, we're going to use Perlin noise to change just one thing. Instead of using random range to choose what tile to display, we're going to use a Perlin noise. So this right here is how it looks when you're using a random range. And you can see that is just random. Now, if you compare it with Perlin noise, you can see the difference right away. And let me show you how to set that up. So let's go to Added Graph. And right here, I use a random range. So this is the node that I want to replace. I still need to give a 0 through 2 output to the select on integer node. And that's the output that we need to get from Perlin noise. Let's go and find that Perlin noise. And here it is. It has input of X and Y, and it's because it's a 2D noise. In our project, we are placing our tiles in 2D. So we have one loop for Z-axis, and then we have another loop for X-axis. So we can use those index for our input. So with this setup, we can just use those outputs, connect them right here. And the output that we're going to get from Perlin noise is going to be ranging from 0 to 1. So it is a float, and we need to convert that to an integers 0, 1, and 2. We can do that by multiplying by 3. So if we multiply it by 3, now we'll get values from 0 to 3. So one thing we can do to convert that float range to an integer is by using a floor. So there is an option right here, floor to int, and this unit is going to convert to integers. So it is possible for a Perlin noise to give out a number beyond 0.1. That means when we multiply by 3, we might get an integer of 3 from the floor. And that is fine in our case because it's going to be captured by the default. So the default is going to capture 2 and 3 values. So it might have slightly more of gravel than the other ones, but I don't think it's going to be that noticeable. Okay, that's all we have to do to replace that random range with Perlin noise. We can now test it out, but it's not going to actually work as we want it to work. And let's actually take a look at that. So right here, you can see that all of our tiles are actually green. And it's not because the Perlin noise is not working. It has to do with the Perlin noise resolution that we're looking at. So right now, our index is incremented by a whole number, 1. And at that scale, all the output from Perlin noise is really close to 0.5. And because of that, we're actually displaying the grass, which is integer 1. So that means if we want to see more details of this noise, we need to actually scale down the steps. And we can do that by using multiply by a scalar. So let's use a 0.5. We'll duplicate that node and we'll do the same thing for the other axis. Okay, so by multiplying by 0.1, we are looking at 10 times more detail of the Perlin noise. And let's see how that's going to look now. So now you can see better how the Perlin noise actually looks. So we increase the detail by 10, and these are the tiles that are created now. But you might actually see something interesting, and it's this mirroring effect. So let me go to y-axis, and you might be able to see that more clear. So we have this mirroring or reflections that are going on here. And it's due to how Perlin noise treats negative numbers. It's just taken an absolute value of it, which creates this reflection that we see. So to fix that, what we can do is actually shift X and Y away from the negative position. And that should work for a simple case that we have here. Let's do that. Let's add an add node. Then let's shift it by 10,000. Duplicate it for the other axes and pass it in here. Okay, let's exit the full screen, click play, and we should see that mirroring go away because we moved away from the center. But if you continue generating into negative 10,000, then you're going to see that issue come back. I'm not going to go about how to fix that in this video. I'm just letting you guys know that the problem is still there. So I hope you guys enjoyed this quick video on Perlin noise. You might use it for some cases where you need more of an organic generation of something. If you liked the video, click on the like button, subscribe to my channel, and I'll see you in the next one.